this lesson is going to be on colligative properties. So colligative properties are going to be solutes that affect physical properties of their solvents. So the properties that are affected by the number of particle, but not necessarily the type of particle, are called colligative properties. So some colligative properties are osmotic pressure, vapor pressure lowering, boiling point elevation, and freezing point depression. And we're just going to look at the last two, the boiling point elevation and freezing point depression. So elevation means you're raising, so colligative property is boiling point elevation. If you add a solute to a solvent, you can increase that solvent's boiling point. And the same thing is going to go for depression. So depression is lowering, so you would lower the freezing point of that solution. So for the boiling point, remember that's when a liquid's vapor pressure equals the atmospheric pressure. And if you have a non-volatile solute, that's something that has a very little tendency to become a gas. So think of table salt for this example. When you add a non-volatile solute to a solvent, the temperature of that solution is going to have to be increased to reach the boiling point. So if you have a pan of pure water, you try and boil it, it's going to have to boil at 100 degrees Celsius. If you add enough table salt, you're going to have to increase the temperature of that substance, of the solution, to get it to boiling. So that temperature difference is called the boiling point elevations. So delta meaning a change, T for temperature, B for boiling. So delta TB is the boiling point elevation. How much did you have to increase the boiling point once you added that solute? Next is the freezing point. So particles of the solvent aren't going to have enough kinetic energy to overcome those interparticle attractive forces, those van der Waals forces pulling them closer together. So a more organized structure is going to be formed as you drop the temperature. And the solute is going to interfere with that process and lower the freezing point. So when we had snow and ice on the roads, they spread salt. Well, that salt is going to interfere with that organized structure forming, and it's going to keep it as a liquid at a much lower temperature. And that temperature difference between the normal freezing point and the freezing point with the solute is the freezing point depression. So delta TF, the change in temperature of our freezing point. How much did it drop? So you can see it on a phase diagram. This solid line here is your pure solvent. So this could be pure water. And then this dotted line here is going to be if we added salt. So this is going to be your solution. So you can see here is the melting point of just the solvent or the freezing point, and when you have the solute added, the temperature drops to here. So now here is the melting point of that solution, or the freezing point. So you can see that the melting point, freezing point decreased. It's a depression in the temperature. And here is your normal boiling point, and when you add that solute, you increase the temperature there. So now your boiling point of your solution is higher than the boiling point of your solvent. So this is the boiling point elevation.